Welcome to this walkthrough of how a hydrogen fueling station works. At first glance, a hydrogen station may look similar to a conventional gas station. However, behind the dispenser is a sophisticated network of storage vessels, compressors, cooling systems, safety equipment, and digital controls designed to safely deliver hydrogen fuel to vehicles. Hydrogen arrives at the station in compressed form and is stored in high-pressure tanks. Before it can enter a vehicle, it must pass through multiple stages, including cooling, compression, pressure management, and safety verification. Each component plays a critical role in ensuring hydrogen can be transferred quickly, safely, and efficiently. In the next few slides, we will follow hydrogen step by step through the station and uncover the hidden engineering systems that make hydrogen mobility possible. Let's begin with the overall layout of a typical hydrogen fueling station. Hydrogen enters the facility through a delivery trailer and is transferred into storage tanks. These tanks act as an energy reservoir, holding hydrogen until vehicles arrive for refueling. The hydrogen then moves through a pre-cooling system. This stage is important because hydrogen heats up during rapid filling. Cooling the gas helps protect vehicle tanks and improves fueling performance. Next, hydrogen enters the compressor system, where pressure is increased to levels suitable for vehicle fueling. The fuel is then stored in cascade pressure vessels that maintain stable fueling conditions. The dispenser is where drivers interact with the station, but behind the dispenser lies a highly engineered infrastructure that continuously manages hydrogen flow, pressure, temperature, and safety. Now let's trace the journey of hydrogen through the station. The process begins with hydrogen delivery and storage. Once stored, hydrogen passes through the pre-cooling equipment, where temperatures can be reduced to approximately minus 40 degrees Celsius. The hydrogen is then compressed to very high pressures. Many stations operate at pressures approaching 900 bar to support fast vehicle refueling. After compression, the fuel enters cascade storage vessels. These vessels contain hydrogen at different pressure levels, allowing the station to optimize fueling performance and reduce stress on compressors. When a vehicle connects to the dispenser, hydrogen flows through the dispensing system and into the vehicle's onboard tanks. Throughout this entire process, sensors and control systems monitor operating conditions in real time, ensuring safe and efficient fueling. This slide highlights the engineering systems that work together to deliver hydrogen fuel. Notice the network of pipes connecting every major component. Hydrogen is constantly moving through storage vessels, cooling systems, compressors, cascade buffers, and dispensers. At the same time, electrical systems power the station while cooling systems regulate temperatures. Control systems continuously monitor every stage of operation. Hydrogen fueling may appear simple from the driver's perspective, but behind the scenes, the station is performing thousands of measurements and control actions every second. The objective is to deliver hydrogen quickly while maintaining strict safety and performance standards. A hydrogen fueling station functions as a fully integrated energy system. Each component depends on the others. Storage tanks provide fuel inventory. Cooling systems manage temperature. Compressors generate the pressure required for fueling. Cascade buffers balance pressure fluctuations. Monitoring systems ensure reliability and safety. The challenge is maintaining stable operation while meeting customer demand. When a vehicle arrives, the station must deliver hydrogen rapidly without exceeding temperature or pressure limits. Advanced automation coordinates all equipment to achieve this balance. This integration allows hydrogen stations to provide refueling experiences similar to conventional fueling stations while supporting a zero-emission transportation system. Now we arrive at the actual fueling event. The driver parks next to the dispenser and connects the fueling nozzle to the vehicle's hydrogen receptacle. Before fueling begins, the station performs multiple automated safety checks. These checks verify secure connections, communication between the station and vehicle, and operating readiness. Once all conditions are satisfied, hydrogen begins flowing into the vehicle's storage tanks. Throughout the fueling process, the station continuously monitors pressure, temperature, and flow rate. Adjustments are made automatically to ensure safe operation and optimal fueling performance. Within approximately 3 to 5 minutes, the vehicle reaches its target pressure and fueling is complete. The nozzle is disconnected and the vehicle is ready to continue its journey. Modern hydrogen stations rely heavily on digital monitoring and automation. Hundreds of sensors collect information from across the facility. These sensors measure storage pressure, compressor performance, cooling temperatures, flow rates, and safety conditions. All data is transmitted to the station's control system, where operators can monitor performance in real time. If abnormal conditions occur, automated alerts are generated immediately. Safety systems can isolate equipment, adjust operating conditions, or shut down portions of the station if necessary. Remote monitoring capabilities allow operators to supervise multiple stations from centralized control centers. This digital layer transforms the station into a smart infrastructure asset capable of operating safely, efficiently, and reliably. We have now completed the hydrogen fueling journey. Hydrogen has been delivered, stored, cooled, compressed, buffered, dispensed, and monitored before reaching the vehicle. The result is a transportation fuel that can be refueled in minutes and produces only water vapor at the tailpipe when used in a fuel cell vehicle. Behind every fueling event is a sophisticated combination of mechanical engineering, thermodynamics, pressure management, safety systems, and digital control technologies. As hydrogen infrastructure expands around the world, fueling stations like this will play an increasingly important role in supporting fuel cell cars, buses, trucks, and other zero-emission transportation solutions. The next time you see a hydrogen fueling station, you'll know that beneath its simple appearance lies a highly advanced energy system designed to move hydrogen safely from production to mobility. To learn more about hydrogen infrastructure, fuel cells, electrolyzers, project economics, and the hidden engineering systems behind the hydrogen economy, visit H2 Hub by Renee Energy.